H Tech Services is here. Trader Jabari is here. And today we have a problematic MacBook that has been trolling me for the past several days. And I'll show you what we did on this and what's wrong with it. So this one actually does boot into the operating system. It will boot just fine. It'll work just fine. However, if we plug in the battery, we have a very strange condition going on, and I'm probably going to have to cut out the stream here in a minute because someone is here. Or maybe not. Maybe they just don't know where they're going. But so if we plug in the charger, we get a green light or orange light. It chimes, we get fan spin and all that. But if we plug in the battery, so we're going to plug in the battery. So let's do the same thing. Green light, no green light. Green light, no green light. Green light, no green light. And watch the fan. When the green light goes out, see that? Pretty strange. So, what is most likely going on with this is we have an issue with our charge circuit. Now, the charge controller circuit on this was a mess to begin with. That is mostly fixed. However, we do have some issues remaining, and I'm going to have to go through and replace all the FETs and the ISL again, and I'll explain what we're going to do to make sure this doesn't fail again. So, once I get the board out, I'll show you guys what was done to it, what happened to it, and what some voltages are, because this board is a mess right now. It'll work, but yeah, we have a major problem in that circuit, and I'll show you what that major problem is. Hate disassembling retinas, especially these 15 inches. There's so many screws. Still better than a touch bar, though. Any more screws? Nope, just this stupid connector that I always miss. There's this connector by this ribbon cable by the fan, and I always forget to unplug that, and I never ripped one, but I still end up pulling it. So here's our board. Let's have a look. So what was done on this is, as you can see, the FETs are obviously replaced. We have a lot of wires, so both gate pins were blown out. So this is the gate, and this is the gate right here, which is broken. So I ran a wire, and I routed it. I just didn't want it crossing over here. I routed the wire around these capacitors on the other side to the ISL right here, and then right here. So now let's talk about gate. So what gate is on a transistor is basically the enable. If the voltage, depending on what type of transistor you have, if voltage is lower or higher than source or something, it will open. So think of gate as the enable, basically. And both pins on the enable from the original ISL, the ISL exploded, blew out the trace under here, and it screwed up the MOSFETs, obviously. So those MOSFETs were replaced. Q7080 was also replaced. We don't have to touch this yet. This is just fine. We had to run wires under this too because this was destroyed. It was actually welded to the board where I pulled it off, ripped these pads off. These are NC, these are NC. The only couple you need to worry about are the ones underneath of it. So how did these FETs fail like this? So let's plug it in and let's measure PP bus voltage. So we're going to plug this in. Turn on the oscilloscope view here for you guys. This buggy software that is absolutely terrible. So here's our oscilloscope view. Let's go ahead and measure PB-bus G3 hot. So PB-bus G3 hot is our main 12-volt system supply rail, and that needs to be at around 12.5 to 12.6 volts for everything to work properly, including charging. So we're going to go ahead and measure this on the backlight fuse right here. Or what am I doing? Wrong lead. We're going to measure this on the backlight driver. And what do we get? 19.9 volts, which is no good for PB-bus. What 19.9 volts means is that our MOSFETs right here are basically passing charger voltage to the, basically there's a couple things going on. So one, the ISL is not telling these to switch, and two, these are basically just passing charger voltage onto our system. That is obviously not good. We don't want that. So what we have to do is replace these MOSFETs as well as the ISL again. Now, these MOSFETs right here are basically Apple OEM. This is the MOSFET Apple uses. They are 30 volt, 30 amp, and they're just not the best out there. We're going to be replacing them with much better MOSFETs that hopefully will survive. Secondly, the vias for gate are going to be, so let's see, this is going to be our gate trace. Oh, wait, no, that's not gate. Did I screw up on something? No, I don't think so. I don't know if that's the gate trace or not, but the gate pin, you want the shortest length possible. Now, for both gates, there's a via on the board that goes right to the other side of the charge controller. That's obviously not going to be possible now, so we have to run a wire. Now, if you increase gate impedance, you risk the FET failing. So that's another reason why we're going to use a better rated FET to kind of counteract that. But we're also going to get rid of this. We don't want this routing. I thought, let's try it so it's not, so it's just a better routing. I don't really care about that. We're just going to run them straight over here to the FET in the most direct way possible, even if it's doesn't look the most professional or anything like that. So I'm going to start by ripping all this up. We're going to replace our ISL, get rid of all this green conformal coat, and then replace these two FETs with a better FET. Now, in addition, we're also going to replace this FET. This is for the battery. Now, you saw the condition it had with the battery plugged in. We also don't want this on the board, so we're also going to replace this with the same high-rated MOSFET. I think that'll work in this. I have to look at the schematic again, but as long as we're P-channel or whatever these two are, then we should be fine with that other MOSFET. So I guess we'll start with the ISL, since this is going to be the biggest pain running wires under the chip. So I'm going to go ahead and do that now. So kick fume extractor on, quick on. This nozzle will not work. We need a nice big nozzle, especially for those MOSFETs. That little one will not do the trick. I like that little one for stuff where I don't want to necessarily mess up, connectors and stuff, so I need a relatively precision airstream. So it would help if I moved my fume extractor closer to the chip. We don't want all this green stuff on the board. It's really not going to hurt anything, but I still want to kind of scrape it just so it looks cleaner. It really doesn't matter, I guess. Actually, yeah, I don't even care. Next off is these FETs. This is just a little ground wire because that pad was ripped. I ripped it when I was soldering I was being lazy and using the iron to do it because I didn't want to use the hot air for some reason. And it, ground pad, ripped. Yeah, see how this whole area of the board is kind of bubbled up? That's what happens. It's pretty bad, actually. Yeah, that's really bad. Because it's not only... Have you tried using a preheated in order to easily... No, there's no need for preheater on this. You saw how quick the hot air station did it. So this is pretty bad. I'm not too really concerned about it, but it's just, it makes it a pain to rework. There's really nothing we can do about it. Since the trace is still mostly there, it usually won't be a problem. But all the layers underneath are a different story. Since, look at this, the whole board is... How this happened is the MOSFETs right here, they shorted originally, and they got very hot. So, you know how these MOSFETs were probably hot enough to desolder themselves from the board. And the place, well, I don't know, but apparently they replaced the charge port first, like that would help. You know, it's like, come on, you see the MOSFET is... This is why I'm starting to dislike doing a lot of work for shops. It's, you know, it's dumb. Replace charge port, but yeah, but you see the MOSFET is just destroyed. You know, what is the charge port gonna do? So I'm gonna go ahead and solder some new FETs in. I'm gonna use ST Micro 105Ms, which are a very good FET. They're they're high rated, 105 amp compared to 30 amp that Apple uses on this board, and they will do very nicely. The next concern is obviously going to be the gate pins. And I may want to run that wire under... Yeah, you know what? I'm probably going to have to run the wire under the FET too, because I want the lowest resistance possible on gate, or else they're going to fail again. So we're going to run the wire under gate, I think. Which is going to be a little bit of a headache, but we will handle it. This I don't like, honestly, how it's bubbled up like this, because that makes it hard to rework. And the heat obviously is just going to make it worse. Let me go over to the board view real quick. Let's have a look. Make sure I'm not soldering something to the wrong pins. Let's do the ISL first, because that's going to be easier. Not easier, but I think it's going to be easier for me to rip off the little excess wire if I do the ISL first, rather than do it on the FETs first, then have to deal with this, which is, you know, some much smaller pads and more precision. I'm going to leave this here. Let's kind of scrape up this conformal coat a little bit so I can expose the via underneath. Yeah, this is still good right here, so what I'll just do is run a wire to where this is exposed. flux. Soldering these QFNs when you have a wire underneath is a real pain, honestly. At least for me it is. Better than BGA, but still no fun. So that one's good. We'll just put a wire around here and route this the same way we did on the other one. But this one we're going to run the wire under right here, up around the ISL, and over, so with the shortest path possible. Now I could not have to do that if I used a thicker wire, but this 37 AWG is about the thinnest or the thickest we're going to get without having the chip not sit right or touch the other pads, and it'll just be a huge pain to work with. Jumper wires under chips are no fun. At least it kind of helps on this having the pad, where the other one didn't have the pad. So I'm just going to kind of run that wire where it's not going to bother anything right now because it's going to be routed on the other side of the board. We're also going to risk burning it a little bit, but that's okay. We're going to make sure to conformal code it to make sure it's not touching anything and we won't have any issues. We're going to go ahead and drop our chip in now. Let's clean this up and put some fresh flux there. Arnold is here. Aligning the chips with solder, or with wires running under them, is also a huge pain. That's probably the hardest part. You'll see why in a minute. Need more ISLs. So we're gonna have to kind of try the hardest we can to have this aligned before we put heat on it. So what I'm gonna do is turn my microscope like this. So kind of see how it's at an angle now. And this is gonna help me kind of see where the pins are. And we can go ahead and start heating. We're gonna go to lower airflow because I don't want to blow it away or mess up the wire. I can't really see because of the flux too. But remember, you only need to see a corner really. Normally I don't even hold these, I just heat and they fall into place, but when you have wires, you're gonna have to hold it, and which sucks for me because I have really bad hand control. There, and see, it's not soldered, and we knocked our wire off right over here. This is one of the things you have to watch out for. As long as you catch it, it's fine. But if we soldered gate to the one next to it, we would have had a dead MOSFET again. Dead MOSFET and ISL actually. That's good. More flux. Good alignment. The alignment, you're really not going to have control over it until the flux starts to melt, and when the flux starts to melt, you have (10 to 20 seconds before all the pins underneath are liquid. So this looks pretty good from what I can see. And go ahead and start heating. Be a little bit more this way. Off heat. Now I can push it down a little bit. And that soldering looks like a 9-year-old did it. Not even close. At least now we can move our microscope back normal and fix the alignment since it's already down there. You know, people solder them like that and leave them crooked like that and send them to me sometimes. Which is just sad. At least I fix it. When I mess up alignment, I fix it. Some people don't fix it and they just leave it sideways like this. Alignment is good. Apply some pressure. And we should be good there. Looks aligned good. Not perfect, but you're not going to get perfect when you have wires under the chip. At least not usually. Now we can go ahead and solder the rest in with the iron. Those pins are a little bit off, but I think we'll be okay. I mean, when I was starting, I would solder them when they were off, and they would work fine. So we should be fine. We're not going to disturb our wire. We're just going to touch up the pins like right here. When the chip isn't sitting flat, it's going to be almost impossible to get 100% good alignment. Just make sure you're not shorting any pins, and you'll be fine. Okay, so where does that pin go to? Which MOSFET? That is going to be Q-gate, which I believe is 35. No, Q7030. So this is going to go. How we're going to route this is we're going to pull this away from this. We're going to route it on top of the chip. Now, this will kind of put it at prone for breakage at the joint, which isn't going to be good, but we're going to conformal coat it, and hopefully it won't break. I may want to consider running it kind of like that. What I'll do once it's soldered and I have tension, I'll put more solder on this so it won't, and then conformal coat up around there, but it's going to be a risk we're going to have to take, because there's going to be no other way that we're going to get this thing to work if we don't have that like that. So we have to go to the shortest possible path. Now, with this FET not being soldered, you know what we have to do? We can't even do this one yet. We need to solder the other FET first and do the other one. Because else we're going to end up running that other wire underneath or something, and that wouldn't be good. That. I'm still a little bit concerned that the impedance is going to be too high between the ISL and the FETs, and it's going to blow them again. But we really, there's no other option here. And my wire just fell and all unraveled. The only other option would be, yeah, there is none, because the gate vias are blown out internally into the board, and yeah, that I could drill a small hole where the via was, but I don't have a drill bit small enough. I don't even know where the via is. It's probably under the ISL or in some strange place. But if the via was visible, what I could do is get like a small dental bit and drill through the via and then run a wire through there, and that would work. That would be better, but you're not going to find that via. And for all you know, it's going to, you're going to go through another layer with something important on it. Okay, so this wire is our gate. We're gonna we don't care really where it is on the other side. We don't care how pretty it looks or what it's crossing over, because we'll conformal coat that and handle it then. I always try and like to make my wires look nice, but if in a situation like this, it really doesn't matter. What matters is, does it work, and does it work reliably? Let's grab MOSFET. These FETs, I usually get a reel of them. They are good to have. These are 105 amp, and you could use them pretty much on any board or on anything really for replacements. Arrow, Mauser, DigiKey, all of these should have them. They're discontinued, so don't buy over 2,000 of them, or I'll buy those all. I honestly prefer Arrow for most stuff. One thing I have been liking about Arrow is they've been sending stuff priority overnight. Usually it's free standard overnight, but they've been sending stuff free priority overnight. And sometimes I don't get here until 10:30, and priority overnight would have already came by then, so that could get irritating. But at least FedEx Express will come back, unlike FedEx Ground that will just leave it wherever if I'm not here, which, yeah, I don't recommend FedEx Ground at all. Wait, what am I doing? Wire. Do I run it over or under? I don't know. Or around. I'll do it like this. No, then it's going to go under the board. So yeah, over this FET through the side is going to be the safest option. like this. Even though it looks really bad, kind of like, you know, some moron did it, which isn't entirely, that's actually not entirely wrong, because a moron is soldering on this right now, but you get my point. I don't like how that's touching drain like it is. I think that should be good. Let's grab our new MOSFET. I hope this works. Hi, did you show up for work today? No, you go back down there. I don't know why this is there. It can be crooked for all I care. See if I'm connected. So we're gonna do, not certain that this is honestly connected. And if we start it without the gate, then it's not gonna work. It's gonna kill the FET immediately. At least I think it would. So diode mode, we should not have open line here. And we don't. We have 987. Let's measure on the ISL and see if we get a different diode mode reading. If we get a different diode mode reading, we know we screwed up. A little bit higher. Do I take it off or try it? Let's try it, and let's see if it's still 19.9 volts. If it's still 19.9 volts, or if it goes to 19.9 volts shortly thereafter, I will probably cry, because this has been here for too long. Okay, green light, green light. Darn it. You have to pull this one. I don't think we turned it on. Whoa. What? It was unplugged and it just sparked. No, that was connected to gate. I think I've spent too much time on this board. Okay, last time soldering. If it doesn't work now, then probably rest in peace. Let's inspect around. Let's check if PP bus is shorted already. If PP bus is shorted already, then I'm moving to the next one because it's going to be dead ISL and FETs again. Because I think the board, I'm almost starting to think the board is just too messed up internally. No short on PP bus. Let's give it another try. Charger plugged in. Now. Green light. Fan spin. This gate wasn't connected right. Now, here's the next test. Is our FETs going to burn me if I touch them? Not yet. They're hot. That one's really hot. Maybe because I just still soldered on it. What is PP bus voltage now? This is the real test. Is PP bus 19.9? Is it 12.23? Is it 12.56? Is it some weird value like 10 because the ISL isn't telling the FETs to switch right? Let's see. Something smells like it's burning. Hopefully it's not that board. And yeah, the software screwed up. And it's 12.6 volts. You guys probably aren't going to see that because the software is messed up. But yeah, it is 12.6 volts, which is good. So now let's test it in the enclosure. I guess, should I put this cap back? Yeah, screw it. It doesn't need that. It doesn't need that cap. Go turn on the ultrasonic because we're going to need it. And let's reassemble it because I hope this works. And if it shorts to 19.9 volts again, yeah. I probably won't do it again, replace the FETs like that because it's... Oh wait, we did not change Q7055. It would have done it. I screwed up. We have to change the battery MOSFET. Let me make sure that this will work first. Let me look at the schematic real quick. Q7055. $820-3332 PDF. Q7055 should be the same. whenever you change MOSFETs from what their design spec is, and that's P channel, not N channel. Alright, let me find another one of these. What is it? 7137W51C. Stolen. Seven one three seven. %100% fix. 1000% fix. Working MacBook. We could have just rehotted that MOSFET and it would have worked. Actually, what we could have done originally to the original MOSFET that was blown up and exploded, we could have just rehotted that. So if we would have got a hot air and at 500 Celsius with no nozzle and just took it to the board with the exploded MOSFET right here and just heated it for like 5 minutes, that would have fixed the board, completely avoiding all of this. So if you have an 820-3332 with exploded MOSFETs, all you need to do is just heat them and they will work again. Absolutely no need to replace them or the ISL, just heat. And that'll completely fix your board. In fact, you don't even need to heat the MOSFETs if they're broken. You just heat the CPU. If you heat the CPU, that'll automatically fix every single issue on the board. So there's zero need to do any kind of rework for any problem on the board. Liquid damage, you see corrosion on your clock chip or on your ISL, no need to fix any of that. Just heat the CPU. That's all you need to do. That'll completely fix your board. Okay, so we're going to boot into an operating system here. SSD. Where's SSD? No, you don't fall out, motherboard. Rehot CPU, bro, is 100% correct. Plug it in. The charger light flashed. What's up with that? Don't even tell me they just shorted again. As soon as they have load, I think, they just quit. And that's because of the gate wire, I think. Let's see. What's voltage? We're booting into an Apple logo. 12.59 volts. Alright. So far, so good. And it booted. But we don't have a battery connected. What happens if we connect the battery? Will it do the same weird power cycle thing? Here we go. fan spin, and quarter fan spin. So this might have a bad battery, and that may have been why it exploded. You can never trust boards that have been messed with like this. So in this case, what I'm going to do is I'm going to replace the battery in this, and of course bill the customer extra because I charged way too less for this. Never give wholesale discounts to someone that might be messing with the board. It's still 12.50. Yeah, it's still 12.56 volts. Let me show you guys the meter so you guys don't believe me. Gotta take lunch at some point. Who needs lunch? Who needs food or water? Nobody needs that stuff. So, here's the meter. Show you guys I'm not lying. Okay. $12.6, or was up 19 point something, and it just happened to short right now. $12.6. So this is fixed, I think. Just needs a new battery, and that's it. Luckily, we caught it quick enough before the bad battery killed Q7055. At least I think that, unless... Where's our donor board? No, I put everything back. Okay. So I think we're good there. Let's go ahead and set this aside. Needs a battery. And I'm going to make sure at least I put a used battery in that, because I know when they get it back, the customer's going to think, oh yeah, you know, it doesn't really need it. You know, they just recommended it, and I'm going to try and see if it works without it. And they're going to plug in the bad battery, and it's going to kill the new FETs, and then they're going to complain and say, hey, you sent this back to me, and now it's not turning on. And then I'm going to tell them, did you plug the old battery in? Well, yeah, I thought you just recommended it. I said, no, it needs a battery or else it's going to kill the board again. If I say that, they're going to flip out and be angry. And say, I thought it was flat rate. What are you doing? I thought everything is flat rate. You never said anything about a battery before I sent it. So that's how we avoid that. We'll put a junk battery in. It's not even junk. It's just used. And if they want to put a new one in it, then they can put a new one in it at their discretion. Next board. It's a MacBook Air with the complaint of a coffee spill. Somebody spilled coffee on a MacBook Air. The MacBook Air doesn't like caffeine, so I don't recommend you give caffeine to your MacBook Air. MacBook Airs don't prefer coffee. So far it looks pretty clean. And there's coffee right here around U1950, poor U1950. There's coffee in a lot of places, under the camera's IC and stuff, under the RAM, under the TPS 51980. Near the clock chip too, I think. Actually no, the clock chip is okay. That looks nice. So, what does this even do? Does it not turn on? Does it not post? Does it beep? Let's plug it in. Let's plug in the charger. And the fan does not spin. So if our fan does not spin, what does that mean? we need to check our first power rail on the list, which is PP-Bus G3 hot, which is also near the corroded clock chip. I mean, they had corrosion on it. And PP-Bus G3 hot is 15.9 volts. Another one. Okay, so PP-Bus G3 hot is 15.9 volts. Now, that's actually, it would turn on with 15 volts. But that is obviously no good. So, just in case you guys don't believe me, we have 15 volts on a power rail that's supposed to have 8 volts, which is no good. So, what's going on here is going to be the ISL is not switching currently. The ISL not switching is going to tell this FET right here to constantly send 16 volts to our PP-Bus G3 hot. Let me, right here. So, what we have to do is replace that, and replace our ISL, and everything around it that looks bad. And then replace U1950 and just refill this whole area to get rid of the coffee. And there should be a happy MacBook. So we're going to start by cleaning this a little bit, just so it's a little bit easier to work on. We're going to get rid of this. And add the proper amount of Amtech NC559. Just like that. Now we could heat. At least the coffee smells a little bit better than the whatever the heck was on that one the other day. The one the other day did not smell pleasant at all. Lovely, we're going to have to run a whole lot of wires. Oh, no, we're not. No, we're not. We're fine here. The coating is all corroded, though. That's no problem, though. See, after the cleaning, we have a little bit of an issue right here. There's no pad there, and we have a break right here. But that's not a problem. We'll resolve that. So first off, do we really have a break here? No, we have pads here. Here we don't. But I'll run a nice little wire. Let's see what that's for first. So I can decide whether I need a wire before we place the chip or after we place the chip. I think this is no stuff. You will need a jumper. Okay, not too bad. Let's start. So let's see what that one pin does, if that's a gate or anything. Hopefully it's not a gate. This is an 820.34.0016. It's a 00165, but the 3437 file is closer, so I will use that instead. That's PP3V42, so that's, yeah, I could run that after. This one over here, C, yeah, that's kind of important. We'll need to run a wire from, on the other side of the board to that capacitor, which isn't a problem. We'll handle that. Anything else? This one right here, C7102, that is not no stuff actually. That's important. We'll need to run a wire to that bottom pin, which is 3V42. Okay, this will work out nicely. So let's start. First off, flux. Yeah, that 3V42 pin is actually gone. I'm still going to run it after I place the chip. I'll show you guys how I'm going to do that. But I usually will do that, and it's fine. Yeah, is there probably some electronics engineering thing that tells me why I shouldn't do that? Yeah, but I haven't had a problem. It's dependent on the pin. Gates, yeah, it tends to be a problem, but I feel hungry. I should probably stop and eat soon, but where's time for that? So on the MacBook Air boards, instead of using two MOSFETs, they use one dual. It has two transistors inside, basically. You tend to see less failures on the ones that are dual N-channel or whatever, compared to the ones that are not, to where they have two MOSFETs. I think it's a little bit less load on the ISL, so maybe the fact the ISL is underrated. Not underrated, but it might be underrated in a certain circumstance, like inrush or something. Really don't know. Companies would never cheapen the parts they use to save a few pennies, right, on Razer computers? Yeah, right. Yes, fair enough, that is absolutely right. The first troubleshooting step that you should do to your own board when it doesn't turn on, even if it has liquid damage or obviously corroded components, is to just rehot the CPU. And that'll 100% fix your board before you send it here. So there's not even any need for me to be here anymore. Because clearly, what I am doing is just scamming people. I mean, I fix boards, and you don't even need to fix boards. All you need to do is just reflow the CPU. That's 100% fix on anything. Hi, how can I help you?
Hello?
Yes, hi. How can I help you?
Hey, this is Lawrence from A Plus Computer over here in Apple Valley.
Hi.
Who am I speaking with?
This is Tim. How can I help you?
Oh, hey, Tim. Hey, last year we had some credit with you guys.
Yes.
I've got a MacBook Air that was repaired once before by, I think, R&R Repair, and I had a previous, I think, water damage, and
Okay.
now there's no backlight again after a year.
Most likely what happened, either it's going to be a bad screen, or their original repair failed, or they left flux on the board in the backlight circuit and it corroded. But yeah, send it in and we'll take care of it.
Yeah, I put it on a different screen and it's
Same thing?
no backlight either. So
Okay.
It's on a working screen. Okay, should I just I don't have to fill that up, everything again online, right? Just
no, just
ship it to you?
yeah. If you would start a new ticket on www.tcrscircuit.repair, you'll see a tab that says "Send in your device." Just start a new ticket, so I have the ticket information and stuff like that, and send us the tracking number when you do ship it.
Okay, all right, Tim. Thanks.
No problem. Thank you.
Bye-bye.
Bye. Okay, what was I doing? Yeah, so what I used to do is have an option on my website to prepay for board repair, and that is an absolute 100% awful idea. So here's the thing. The repairs that are prepaid are usually going to be ones that are just miserable. You know, like one was, oh, well, just, yeah, sometimes it doesn't turn on right, or, you know, dead graphics chip, something like that, and they'll prepay for that. And it seems like all the good repairs were never prepaid, but all the ones that were always going to be refunded were prepaid. So like dead GPU, dead GPUs, random not turning on, not random shutting off, random not turning on. Beeping on a 2011 Air, that was the only stuff that was prepaid. And yeah, don't allow customers to prepay for board repair for any reason. It's a terrible, terrible idea. That's why I stopped doing it. Invoice when you're done, and that's the only way you should do it. I think almost every prepaid we either refunded or gave store credit for. Some shops prefer store credit over refund. So when there's a warranty or something, I always ask, you know, do you want a refund or store credit? And most of them will just say store credit. What am I doing? And wire time, we're going to scrape away this 3v42 via a little bit. And another thing that I would get with prepaid is it wouldn't be a board issue. So a store would send a repair, and it would have a bad trackpad and stuff, and they would pay board repair rates. And that really is terrible because then you have to refund them. And I don't know what I was thinking off of doing that, offering prepaid board repair. The only plus is that you get to ship it right when you're done with it. That is the only plus to it. After we fix this board, I'm going to go to lunch because I'm hungry. and we're absolutely slammed here right now. I've had boxes sitting for a week, not even unpacked yet, because yeah, it's just insane. Which is always a good problem to have. I mean, I'm thankful for the work that I have. Local is getting better too. We've had a couple locals. Local board repair too. This is a local board repair actually. Local is going to take some time to get built up though, because basically the culture here is just bring it to the Apple store in Valencia. Because for so long nobody here, did this stuff. It's all, and now a lot of the repair shops are closing around here. I've been on and off about doing iPhone screen repair. It's one of those things, like I don't know if I want to do it or I don't want to do it yet. Maybe I'll wait till I hire someone. Hopefully that's coming soon, because it's too busy here for just me to be doing this stuff. I need help. But California makes it much harder. The goal is honestly work as hard as I can here at this store in this location, and then just get out of California. I messed this up. Come on, get out of here. Some people like California, but when it comes to having a business here, there's zero freedom. It's all license for everything. You can't fix electronics without a license. And the thing is, with the Bureau of Electronics and Appliance Repair, the thing that they push is, it's to ensure consumer safety and this and that. No. If I call Bear to report a shop ripping someone off, clearly, Bear will not do anything. They will not investigate, they'll not do anything. But if I say, hey, this shop does not have a Bear license, they haven't paid you $200 for nothing, they will be out there the next day. Shop ripping customers off to California Bear, they don't care. If they don't pay their Bear license, they'll be out there. It's stupid. It's just a money grab. There's 0 point in Bear. There's no benefits to it. It's all just a money grab. No. There we go. That's good enough, honestly. I'll conformal coat that. The next wire we'll do right here to this guy right here. Yep, they just want your money. That is 100% correct. There's no perks to it at all. And even then, even if you have the license, they'll still come to your shop and harass you every once in a while. It just sucks. I don't want to be here anymore. That's why the plan is just work as hard as I can at this location and get out. There's nothing really here in California for me. The weather isn't very good, especially where, that's the thing. Well, people ask me, well, why do you just like the weather there? It's like, no, the weather is, it's nothing special about the weather here. In the winter, it's 18 degrees. In the summer, it's 118 degrees. What's so special about that? $18 degrees isn't enjoyable, and 118 degrees isn't enjoyable. Spring is nice, and fall is nice, I will give it that. Not very pretty, but it'll work. And this cap, where does this one go? PPV bat G3 hot charger, and that's gonna go right over here to C7117. So let's run a wire. It's actually on either of these big ones right here. Where is it? Right here. What we can do is I think someone's here. My brain doesn't want to work today at all. It feels really, I feel really just slow. I don't know why. I'll conformal coat this all after, but I just want to get my jumper run right now. And then I have to replace that other FET. There we go. Now we have to replace Q7130, which is, I did something stupid. That was stupid. Now I have to remove this, or else the enamel coating is going to get removed and it's going to do not nice things. So we're just going to put that aside right now, under the board where it's shielded from the heat. And let's replace Q7130. We're going to remove the SSD, because I wouldn't want to ruin the SSD. That would not be fun, because the customer would probably be pretty upset at me. Customer upset is not a good thing. Flux. MOSFET comes off. Come on, melt. Hurry up. There we go. Repairs like these always comes in swarms. You always get a very similar issue, you know. Bet there's another more of these in the pile of boxes with the same issue. They always seem to come in swarms. You get run of no fixes 1 week, then better ones, and then MOSFETs, then ISLs, backlight drivers. It all seems to happen at one time. Pull a happier MOSFET off of a donor board. Happy, healthy MOSFET. I can stay like that, honestly. Come on, maybe try and push it over the edge of this cap. Like that. And now, yeah, that's fine. Next area is going to be this. 'Cause this is no good. Cormac is here. I'll run a wire to the 3v42 pin. Not with, I'll run it after the chip is placed, like I did with the ISL. I prefer doing them that way if possible. There's actually a pad there, but not a good one. The 3v42 pin is actually okay, I think. I probably still will run a wire. In the meantime, I'm going to touch up the pins with my iron, as always, since it is no rehot yet. Actually, from all that heat on this side, we did actually rehot CPU right now, because CPU is right on the other side of this. Let's try it. See if it works. If not, we'll run a wire. Poor MacBook. Still no work. Why no work? PP bus is 2 point something volts. PP bus is 2 volts. PP bus being 2 volts is not a good thing. DCN is 2 volts. Oh wait, no. We have open line there. We have blown current sensing. But that kind of makes sense. Actually it doesn't, but do we get PP3V4 too? What is PP3V4 too? PP3V4 is nothing. But the regulator looks perfectly fine. This is gonna suck. PP bus is, nope, not shorted. Is PP3V4 shorted? No. This looks fine. I don't think our issue is right here. Let's plug it in again. Oh, we have 2 volts on DCN. Now is DCN shorted? No. So what that means is my charger is bad and has been trolling me. I'm glad tomorrow is Friday, because then I could take a day off. Let's change our charger. We're going to use a DCPS instead. And what do you know? It was a bad charger. The real test is PP bus normal now, because I kind of still think our battery current sense may be blown. Yeah, that fan is spinning now. 8.54 volts. We're good. I still want to check. Let's check current sense again. Maybe there's junk on the pads and I couldn't get a good reading, so let me clean that. Let's measure one more time. Resistance. Open line. 3.4 ohms, open line. 53 ohms. Yeah, these guys are blown. So I will repeal. Note the OEM charger may get stuck at 3 volts if there's something it doesn't like in DC and MOSFETs or off resistance. Maybe these current sense resistors that are blown. Another thing is that that charger was kind of really abused last week, being plugged into shorted machines. So it kind of died, where it wouldn't work at all, doing the same thing, and then it started working again, so I thought it was fine, and now it doesn't work again. So it's been problematic. My new favorite word, problematic. These current sense resistors were way off, so that's all I'll do. I'll unplug it. But yeah, I wouldn't have any faith in that charger. That thing, I think what happened to that, someone sent it, and I told them don't send the charger, and then they sent it, and then it stayed here or whatever, and they said don't worry about it or something. That's how I got the charger. And we're back to 21 ohms, so we're good. Let's try it again with the OEM charger. Sticky, flux, hate flux. Okay, again with OEM charger. Nothing. Let's try DCPS, and then I'll go get another charger. Okay, here's another OEM charger, 45 watt though. Darn it, something's off. It's probably Q7080. stolen. That's sad. Does this one have it? This one's also stolen. That's even sadder. Do 24... I don't know. Maybe. The one near the clock chip does sometimes. This one's stolen. This one's not stolen. Place MOSFET. No, we don't fix 2011s. Reply to a message. Now let's plug it into the OEM charger. Does it turn on? Does it turn on? What? What about the other OEM charger? The other one is 0.0 volts. Like nothing. I think they're... Yeah, that doesn't sound right. This one, mine. So the other one, which was the customer's charger that they left, and I didn't notice until after they left it on my counter, was 0.0 volts. Mine is 4 volts, 3 volts, going up and down, and the one connected to the DCPS is fan spin. I think my charger is dead, and I think their charger is dead. Let's unplug it. Plug it. MagSafe 2. Leave it unplugged for a few seconds. Plug it back in. This is plug it in again. I don't know, I think I have 2 bad chargers here. I think I'm getting trolled. Check on another machine. Well, you see with that Piranov, that same charger like 20 minutes ago, the green light was flashing on and off. If you rewind, when the battery was plugged in, it was flashing green light on, green light off, green light on, green light off, power cycling the board. And the board, we fixed the board because there was 19 volts on PP bus, but yeah, it was cycling. Let me grab my Air. Let's see. So my MacBook Air, well, not mine, but the store one that I never use and kind of abuse. Is green light, and yeah, I don't know. But either way, it's time for lunch. It's still fixed. I'll go solve that later on after I eat. But yeah, I should be able to fix it. So I'll see everyone later.